Hi, this is Rong-Hao from TU Eindhoven. I'm presenting NFCSense, data-defined recharting motion sensing technique. We realize Fluent, hot-swappable tangible interaction using a single commodity NFC tag reader. By leveraging physical constraints, the system supports various hands-off, multi-tag inputs, and can be used as a wearable. First of all, NFC systems are passive tagging systems that support non-life sizing. They have been embedded in many devices, but they also have been limited to a discrete hand-on interaction style, using one tag at a time, because they cannot solve the collisions of multiple tags efficiently. Previous work make NFC tag more interactive by modifying the tag circuitry, using multiple tags, or using sensor fusion, but this system make the deployment more complex. They also focus on sensing the static states like the location and orientation. On the other hand, we focus on sensing the transient state like the speed and frequency of the motion and require only a single commodity reader and unmodified tag. It's fairly easy to deploy. An unmodified commodity reader can recognize a tag at above 300 reads per second, so it can reliably resolve a frequency of a rotation. Ideally, linear motions can be derived from the path length and the time duration of the tag activation as well. Unfortunately, the tag activation behavior is hard to predict because it depends on the tag to reader location, orientations, and antenna designs. Therefore, we directly observe the tag activation map using a 3D printer regarding the tag to reader distance, tag to reader angle, tag to tag distance with various types of tags. And then we derive a set of guidelines for designing the physical form of tag tokens, physical constraints, and algorithms, and a lookup table for motion speed with the data. In the following 100 seconds, we showcase the hot-swappable interactivity in one take. The black spinner attached one tag allows the system to resolve its frequency of spinning. The white spinner attached three tags allows the system to resolve the spinning frequency and direction based on the tag presence order. Now we put the swing on the reader. The system resolved the motion frequency of the swing hang-on rack based on the ID of the tag attached to the bottom and report the correct frequency. Now let's add a track as a linear constraint. The bolt attached a tag on the top allows the system to resolve the speed of the bolt sliding on the track from the post width of the square wave. The figuring attached a tag at the bottom further allows the system to recognize whether it is worked or jumped along the track from the tag presence signal patterns. The car with the tilted tag allows the system to recognize whether it is moved backward or forward when sliding on the track. The trolley with the pair of tags allows the system to recognize its movement direction from the tag presence order. Now let's further use gravity to get an object sensed by an effortless release. Based on tag's ID, the system identifies which set of algorithms to use when the user interchanges the hardware components on the go. Physical constraints can extend the input space, like the multiplex, allowing the NFC coin to roll along and get identified from various tracks. The sorter preserves the tag order. In this educational application, the user releases the sorter to resolve the linear order of the blocks. The funnel allows the user to throw tags into it and get each tag through. The modulator further allows the user to throw a handful of tags into a container with one hand and to resolve jams using another hand, rocking the handles before the tags being read. By hooking up a custom finger-wound NFC reader antenna, the user can use the spinner in the mobile context and perform bodily input. A 3-coil non-planar antenna array can reliably capture the speed of a tag-embedded marble rolling on the track. Summary: NFCSense enables rapid prototyping, fluent tangible interaction using simple hardware. We've shown and tested the data-defined designs with existing objects like Lego bricks in the time of pandemic. We further discuss design implications, study limitations, and research direction in our paper. We would invite you to check the tutorial, try the source code, and check our other projects on recharting interactivity. Thank you so much.